Hey guys, we're going to go over some of the conditional probability notes. So far what I've done is just filled in two movies that we are going to determine conditional probability between gender and movie you prefer. So I've just chosen Frozen and Avengers Endgame, and I collected some data from one of my classes. So here's the data of boys and girls and which movie they prefer. So starting with A, I want to see with this sample, what is the probability that a student prefers Frozen? So I'm going to do probability of Frozen equals. Now, what's really helpful when you have a table like this is to find the totals column. So let's total our columns and rows. So for Frozen, there's a total of 9. For Endgame, there's a total of 16. Boys, there's a total of 14, and girls, there is a total of 11. So in our class, I have data from 25 students total. So how many prefer Frozen? Well, I'm going to look here. The total that have preferred Frozen is 9 out of the total in the class, 25. So we've got 9 out of 25. Now, in this next problem, it says, in this sample, what is the probability that a boy prefers Endgame? So I only want to look at the boys. I'm going to ignore the girls for right now. So just for boys then, what is the probability that they prefer Endgame? Well, 12 boys out of the 14 total preferred Endgame. So I'm going to do 12 out of 14. I'm just going to do EG for Endgame. Now, what is the probability that a girl prefers Endgame? So again, I'm just looking at the girls. I don't care about the boys right now. 4 girls prefer Endgame out of the 11 girls total. So 4 out of 11 for Endgame and girls. So D says, is there a relationship between preferring Frozen and being a girl? That is it more likely or less likely for a boy or girl to prefer Frozen? Or we could look at Endgame as well. So for this one, actually, let's look at Endgame because we just found the Endgame probabilities. So right now, what we have is these fractions, but we want to compare and contrast. So sometimes that's kind of hard, not compare and contrast, but just compare. Sometimes that's kind of hard when you're looking at fractions with different denominators. So I'm going to switch these both to decimals. So this is 8.57. And 4 out of 11 is 0.3636. So for boys, it's about an 85.7% chance that you prefer Endgame. For girls, it's a 36% chance. So yes, it looks like there is a relationship. Boys are more likely to prefer Endgame. And so then the flip side, girls are less likely to prefer Endgame. They're more likely to prefer Frozen. Now, those last two probabilities we found in part B and part C, if you notice, they have this word given. So that given was when we just looked at what is the probability that a boy or the probability that a girl. And I said, we're just going to focus on boys, and then we just focused on the girls. And that actually is what our main lesson is about. That is called conditional probability. So conditional probability is where we have a condition. We only look at people that match our condition. So if I want to look at the probability given you're a boy, then my condition is a boy, and I only look at people that are boys. So we can use conditional probability when we care only about a certain group, boys and girls, or juniors, seniors, sophomores, freshmen, any type of group that you really care just about that specific group. So another example here is to look at social media preference. And I'm just going to do a few of these in the video, but the answer key will be posted for you. So for example, what is the probability that somebody prefers Snapchat given they are a boy. So the way that we read this line in between stands for given. And whatever comes second, that is our condition. That's the group that we focus on. So I want to know that the probability people prefer Snapchat given that they're a boy. So only looking at the boys, how many prefer Snapchat? Well, 7 out of, we didn't find our total, so let's do that real quick. 7 plus 5 plus 1 is 13 total. 6 plus 5 plus 3 is 14 total. Going down, 7 and 6 is 13, 5 and 5 is 10, 1 and 3 is 4. We have a total of 27 students. All right, so now, Snapchat given boy, there are 7 boys that prefer Snapchat out of 13 boys total, so 7 out of 13. TikTok given boy, there's 5 boys that prefer TikTok out of the 13 total. And Instagram given boy is 1 out of 13. Now, what happens when I change my condition? Now I just want to look at the girls. So how many girls prefer Snapchat? 6 out of how many girls total? 14. So notice that my denominator is changing because my condition is changing. And then I want to skip down to number 7. 7 says find the probability of being a boy given you like Snapchat. So in this case, I only care about the people who like Snapchat. So we can do conditional probabilities based on the preference as well. So given that you like Snapchat, what is the probability you are a boy? So 7 people who like Snapchat are boys out of the total 13 people like Snapchat, prefer Snapchat. So do we see a difference in which social media sites boys and girls prefer? We don't really see a super heavy difference. Maybe you could say 1 more boy like Snapchat than girls and 2 more girls like Instagram than boys. But is it a very large difference between them? Maybe not. So we can actually test, though, to see if there is a difference between social media preference and boys and girls. And we can do that using this idea right here. So if the probability of event B is equal to the probability of B given A, then A and B are independent. Given this information, are the events prefer Snapchat? And is a girl independent? So in order to determine this, Snapchat and is a girl, I want to test to see if the probability of liking Snapchat is equal to the probability of liking Snapchat given you are a girl. So starting with just the left, the probability of liking Snapchat is all 13 people that like Snapchat out of the 27 students total. So this one right here is 13 out of 27. Now, the probability you like Snapchat given you are a girl, well, here's Snapchat. Just out of the girls, 6 girls out of the 14 total prefer Snapchat. So this is 6 out of, 14. Now, I can't really compare because I have 2 fractions, so this is where it's really helpful to get to the decimal, right? So 13 divided by 27, I get 0.48. And then 6 divided by 14, I get 0.43. Are these 2 equal? They do not equal each other. So these 2 events are not independent. So while we looked at it, and we could say that it doesn't really look like there is much of a relationship between them, boy or girl versus social media preference, according to the data results, we cannot say that they are independent because they are not exactly the same. So what's happening is the conditional probability, I would expect to be equal to the probability of that event in general. So the probability that you like Snapchat should be the same whether you're a girl or a boy in order for these to be independent. And because they're not equal, even though they're close, I would say they're not independent. Now, we have some more conditional probability here, and I'm going to skip over these questions and let you do those for yourself. But what I do want to get to is creating a segmented bar graph. So a segmented bar graph is a way that we can record data in a graph form, and we can break it up based on different categories. So we can create one for females and one for males based on eye color. So we would have to find the distribution of eye colors for each females and males. In order to do this, we want to find the probabilities of each, or the proportions, the percents. So let's start with just the females. So I need to find how many females have brown eyes out of the total number of females. So this over that. Then we're going to do blue, green, and other. So this is 7 over 14, which is 0.5. The next one is 2 over 14, which is 0.14. Then we do 4 over 14 is 0.29, and then 1 divided by 14 is 0.07. And now when I come down to the segmented bar graph, I'm going to label my vertical axis from 0 to 1. So I might do 0.25, 0.5, and 0.75. And I'm going to break up the female's bar based on the proportions we found here. So brown is 0.5, so I'm going to go up to 0.5. And maybe I'll use some colors. So this in here is brown eyes. Next, we've got the blue eye, so that goes up 0.14. So I'm going to go up to 0.64 about. Let's say that's about here. And that was for what? Blue eyes. All right, the next one is green eyes, which is only 0.29. So now adding 0.29, I'm going to be up to 0.93. So that's about here. I feel like maybe the blue should have been a little bit bigger, but again, it doesn't have to be perfect. We can always list our probabilities as well. So if I say this is 0.5, this is 0.14, this is 0.29. That helps since I know we're not going to draw it exactly exact. And the last one is 0.07 for other. So I don't know what color other would be, but let's go with yellow. Now I want to do the same thing for the male. So I'm going to find their proportions. So 2 out of 7 is 0.29. 3 out of 7 is 0.43. And 1 out of 7, both the next ones are 0.14, 0.14. So starting with brown, we go up to 0.29. So brown is about right here. And this is 0.29. Next, we've got blue. Blue is 0.43. So it helps me if I add those two proportions together. That lets me know about how high. So 0.29 plus 0.43, I should be at about 0.72. So that's about here. For blue, then green was 0.14. and other was also 0.14. And so what we've created here is a segmented bar graph. And what's nice about this is that it visualizes the conditional distributions. So the probability that you have green eyes given you're a female is 0.29. The probability you have blue eyes given you're a male is 0.43.